Okay, so in bell work today, I'm doing a couple different bell work questions here to make sure we got an introduction to all these different concepts. Okay, this is a question. We are looking at implicit derivatives, and in particular, we are finding the second derivative of an implicit function. Okay, not necessarily something we did in our notes, but we did it on Friday's bell work. We're doing it again today. It's been on the AP exam quite a bit lately. That's why I'm throwing it in here. Okay, so make sure we're aware of it. So consider this differentiable function, dy dx equals that guy. We're finding the second derivative at the 0.13. So what do I need to do with this first derivative? Find the derivative. What rule do I need to take the derivative of y minus 2 times x squared plus 1? This is a product rule question because I'm taking two things and I'm finding the derivative of them being multiplied together. Okay, so if you wanted to, you could FOIL. Nobody do that. Okay, instead, we're going to do product rule. So we're going to do first times the derivative of the second plus the second times the derivative of the first. What am I going to get if I take the derivative of the first? 1 dy dx. But we got to include that dy dx. Anytime you take the derivative of y, we need to include dy dx. That would be the mistake that students make on this question. But good to this point. That's my second derivative. I'm good. All I have left to do is find it at the 0.13. So everywhere I have a y, I'm plugging in 3. Everywhere I have an x, I'm plugging in 1. So a y, so 3 minus 2. That would be, here, I'm going to write it out. 3 minus 2 times 1 plus 1 squared plus 1 inside of parentheses. Ugh. And then I've got dy dx. How can I figure out what dy dx is going to be? The original equation. I got it right here. It tells you right here what dy dx is going to be. All I have to do is plug in 3 and 1 into this guy. So it's 3 minus 2 and 1 squared plus 1. 1 times 2. Oh, this is 2. No, I just do it. 3 minus 2 is 1 times 2 times, oh, that's 2. Plus 2 times 2. 4 plus 2. It's 6. Make sense what happened there? It looks different. It looks like it's really difficult. But once you start plugging in stuff and working through, it's pretty straightforward as well. Questions on anything? Yes, sir.
Wait, what happened to the dy dx?
I plugged in for dy dx. So dy dx, here it says right here, dy dx equals this thing. And so right here where I needed to plug in for dy dx, I plugged 3 and 1 into this problem. So 3 minus 2 got me 1, and then 1 squared plus 1, oh, that got me 2. So dy dx, the derivative was 2.
Okay.
Other questions? All right, today is going to be a lot of a work day, so to make up for that first, we're going to do a couple more examples here together. This is on bell work. This is bell work part 2. Okay, bell work part 2. Here's the table. It says Joanna jogs along a straight path from 0 to 40. Joanna's velocity is given by a differentiable function v. V of t, or t is in minutes, and v of t is in meters per minute, given in the table. Use that data in the table to estimate v prime at 16, and then using correct units, explain the meaning of v prime at 16 in context of the problem. Go. Work with your neighbor, figure that out, put it on your bell work, see what you can do. So it says she's jogging on a straight path. We are estimating the value of v prime at 16. So they gave me v. I'm trying to estimate v prime. What am I going to look for on this v? The slope. The slope. Which numbers am I looking for if I'm finding v prime at 16? 12 and 20. So it's these two things right here. Even though you are very good at subtracting numbers, you have to show your work. So on letter A, you have to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Can you do that in your head? Sure you can. But if you do it in your head and don't write down the slope formula, you would not get points for this. So make sure you're writing that out. So it is 40 over 8. My answer is 5. That would get you 1 point if you got 5. Okay. 2 is explain it with units. So let's go ahead and do units right now anyways. On top, we've got this 240 and this 200. What does that 240 and 200 represent? That is meters per minute. So this is meters per minute divided by, on bottom we've got these 20 and 12, which represents minutes. So it's 5 meters per minute. You could say that, or 5 meters per minute squared. Either way works. I would write meters per minute squared. We divided by a minute, so that's going to be part of my units. Okay, so that's part A. It's 5 meters per minute squared.
You said 5 meters per minute squared or what?
Meters per minute per minute. I would write minute squared. Letter B says, using correct units, explain the meaning of V prime at 16. Anybody want to take a shot at that? Lulu, what you got?
Okay, I said Johanna's velocity is increasing.
Hang on. Johanna's velocity is increasing.
At an approximate rate of 5.
I can't spell. Hang on. Increasing at, and I like that you said that here. Normally they wouldn't ask you to interpret an approximation, but that's a great job here. She said at an approximate rate, because it's not the actual rate. It is an approximation. An approximate rate of 5 meters per minute squared. At, good, at t equals 16 minutes. That's a great job. Okay, again, looking at what she had. Here's how we would write this out. What they gave us. It was Johanna's velocity. What happened with it? It increased. Okay, at a rate of what they gave me plus the, or what I got plus the units, and then at t equals 16. Yes, sir.
I think I asked you this last week, but if we didn't put approximate, would they count off like?
They probably would not in this case, but it is an approximation, so it's a good idea to have that in there. Questions here? Good. Let's do one more, and I know this is not your favorite one, but let's see what we can do with it. Sorry, I forget to delete my stuff in between. Try this one. The limit as h approaches 0 of that thing right there. Figure out what that answer is. Go. So, we look at this problem. When you look at this, you see this h approaching 0 specifically. When you see that h approaching 0, what does that tell you? This is a derivative in disguise. Okay? And so by looking at that, you're like, oh, man, I hate this question. But I still know what to do. I'm going to figure out what is the function. And then I'm going to find the derivative of that function. And then we're going to find the derivative at a value if they give me one. They don't always have to give me a value, but they can. All right? So the key to this is seeing, all right, h approaching 0. Normally when that happens, it says f of x plus h minus f of x. So based off of that concept, normally it says x plus h. But here it says 2 plus h of that function. What do you think f of x is for this problem? It is 3x to the fourth. And you can also, I think it's easier to see it right here. 3x to the fourth. Oh, it's 3 times 2 to the fourth. Okay, you could see it here though as well. It's 3x to the fourth power because it's 2 plus h instead of x plus h, which would normally just be x. Kind of makes sense where I'm getting that from. All right, cool. I'm going to find the derivative. Derivative of 3x to the fourth would be 12x cubed. Then we're finding f prime at what number here? What value did they plug in for x? They plugged in 2, so it is 12 times 2 cubed. 2 cubed is 8. 12 times 8 would be 96. Yeah, I agree. They look. Two different people just said, "Oh, it looked really hard," but it's not. It's one of those things. When I was in high school, when I had these problems, I hated them. I didn't understand them. I didn't understand them in college, probably necessarily either. But once I started teaching them and understanding them, then they become a little bit more straightforward. It could be this. All right, I don't have to give you an x value. If they gave you this problem and asked you to simplify, this is just f of x would be 3x to the fourth, and f prime of x would just be the 12x cubed, because it's x left in the problem. That's fine too. You just got to pay attention. What did they give me? Did they give me an x value, yes or no? That would affect what I'm doing. Questions with that? Would you? Not necessarily. If they didn't give me anything, then I can't plug anything in. But if they gave me something, then I could go ahead and plug it in. Here they didn't. On this one they did. Here they gave me the 2. That one they just left it as x. Okay? If You are doing those problems. And again, your brain is like, I don't like that. Remember that is why I make this silly website, for you to be able to click on 2.8 random derivatives and then click on these practices. Evaluating disguised derivatives, that will tell you exactly what you need. Okay, you could go through a bunch of those over with help right there. Again, it's right down there to tell you, hey, use a hint, get a hint, and then they will walk you through it one by one and be able to get you through to the answer. Okay, so make sure you utilize.